Presentation of the closed joint stock company, StroyEnergo, concise, STEN. Administrative buildings of the STEN. STEN is a private enterprise. Created 30 years ago. Located in Minsk, Republic of Belarus. The production area is more than 7,000 square meters. STEN, as a general designer and general contractor, has erected administrative, residential, industrial buildings and structures, memorial complex, Katyn, residential building. The building for the assembly of space technology of JSC Pelin. Livestock complex. Indoor skating rink. Garage complex. Residential building. Observation post. Ground control complex of the National Satellite Communication and Broadcasting System. Multifunctional Universal Assembly Shop. Special construction. Development of technologies and manufacture of equipment for the disposal of ammunition. In accordance with the resolution of the Council of Ministers of the Republic of Belarus dated December 13, 2005 No. 1438, KISK, STEN, is the executor of the target program for the disposal of conventional ammunition. State Military Industrial Committee of the Republic of Belarus issued special permission, license, for the right to carry out activities related to military products, including the development and production of special equipment. Certificate for the right to carry out foreign trade activities in relation to specific goods, works and services. The General Director is Leonid Markovets. The First Deputy is Slava Idulov. Head of the Design and Technology Department Sergei Bubnov. Technology has been developed, equipment has been manufactured to extract the explosive A92, compound B, from 30mm shells by the dry method. The manufactured equipment has no analogs in the world. The capacity of the equipment is 1,000 shells per shift. The installation for the extraction of explosives A92, compound B, from shells of caliber 23 and 13 by the dry method has been operated in the Center for the Disposal of Aviation Weapons of the Republic of Belarus since 2019. 30mm shells to be disposed of, without fuses. Ammunition to be disposed of. Preparation of 30mm shells for disposal. Removal of unloaded shells from the installation and placement of shells with pressed explosives. Putting the installation in working condition. Impact on projectiles by broadband pulses of various frequencies. Extraction and installation of the next batch of shells. Explosive A92, compound B, obtained during the discharge of shells. Control of shells for the completeness of the extraction of explosives from them. Operator's room. Equipment for the extraction of explosives by the dry method, located at the site in the center for the disposal of artillery and engineering ammunition. (125mm) projectile loaded with explosive A92, compound B. Extraction of explosive A92, compound B, from a 125mm projectile, by dry method. The precipitation of a crushed explosive substance from a projectile. Explosive A92, compound B, extracted from a 125mm projectile of -26. (122mm) shells loaded with explosive A92, compound B. Extraction of explosive A92, compound B from a 122mm projectile by the dry method. Explosive A92, compound B, extracted from a 122mm projectile of -24. Discharge of fragmentation combat elements 30-10 from 240mm active reactive mines, NERPA, with a cluster warhead. Combat element 30-10, equipped with explosive A92, compound B. Extraction of explosive A92, compound B from the fragmentation element 30-10, by the dry method. Unloaded fragmentation element 30-10. Technology has been developed. Equipment has been manufactured for the disposal of phosphorus-containing artillery ammunition with a caliber of up to 155mm inclusive, with the production of yellow phosphorus in the form of marketable products. Ammunition to be disposed of. Modular room equipment. Control panel. Shells to be disposed of. Caliber -85, equipment, yellow phosphorus. The shells are loaded onto a conveyor to be fed to the discharge module. The work cycle starts. All operations are performed without human intervention. The manipulator grabs the shells and moves them to the position of unscrewing the ignition cups. Operations take place in a tub filled with hot water. The recycling process is displayed on the monitor. The shells are moved to the flushing of the inner cavity. Flushing is carried out with hot water under pressure.
The emptied shells are loaded onto a trolley. The ignition cups are loaded onto the trolley.
The trolley moves to the neutralizing position. The trolley moves to the unloading position. The unloaded shells are unloaded onto the conveyor. Unloaded phosphorus containing artillery ammunition of various calibers. Improved line with a capacity of 400 shells per shift. Projectiles from the slipway are moved by electromagnets into the bath to extract phosphorus.
Flushing of the inner cavity of shells.
Unloading of unloaded shells on a conveyor. Returning the manipulator to its original position.
Work has been done on the disposal of rockets, 9M21 MUNAM.
For these purposes, STEN has developed technology and manufactured equipment. Representatives of STEN and the Ministry of Defense are the organizers of the missile disposal process. A rocket with sweating and leakage of rocket fuel components due to long-term storage. Disassembly of such missiles is extremely dangerous. Disposal of rockets, 9M21 MUNAM in Turkmenistan. Elements of unloaded rockets. Rocket elements containing precious metals. Removal of MUNAM rockets from storage for disposal. Loading missiles onto a transport vehicle. Moving the column to the missile disposal site. Unloading of rockets at the disposal site. Neutralization of the MUNAM rocket engine. STEN has developed a technology for the discharge of rockets for various purposes, incendiary, fragmentation cumulative, to the air defense systems. Universal Launcher MS. Rocket Assembly Diagram. On the launcher there are 12 pieces of 240mm unguided MA rockets with a cluster head, equipped with cumulative fragmentation subelements M. There are 644 subelements in one projectile. A technology has been developed and equipment has been manufactured for the disposal of explosive-free ammunition loaded with PFM-1 anti-personnel mines with liquid explosive. The PFM mine is an analog of the American Blue-43B Dragon Tooth mine, CJSC cassette equipped with 72 PFM mines, 222mm Hurricane rockets, equipped with 312 PFM mines. Hakiki units equipped with 156 PFM mines. CJSC cassette discharge unit. Modular premises of the PFM mine disposal complex. Unloaded CJSC cassettes.
Technological lines with rotary armor furnaces of various capacities for disposal by thermal exposure.
Cartridges of small arms, means of initiation, ammunition with a caliber up to 13 inclusive. Cartridges with a caliber from 5.56 to 14 and 5/10 millimeters inclusive. Cartridges of 7.62. Cartridges of 13.
Artillery fuses. Capsule bushings.
Hand grenades. Incendiary elements. Repop hand grenade launcher shots. Mines against infantry. The line for the disposal of small arms cartridges works. The belt conveyor loads small arms cartridges into the loading device of the armored furnace. Under the influence of high temperatures, their discharge occurs. The bucket conveyor loads the recycling products into the vehicle.
The line for the disposal of small arms cartridges has been operating at the joint stock company, Kazakh Explosion Prom, since 2012.
Row-12 two-way rotary armor furnace at the assembly stage. Disposal of small arms cartridges in Kazakhstan, using the equipment of STEN. The line for the disposal of small arms cartridges, small caliber ammunition and their elements has been operating at the Kisk forepost Baltic Plus in Russia since 2014. Line with rotary armored furnace row-14. Armored furnace row-20 for the disposal of small arms cartridges, ammunition of small calibers up to 13 inclusive and their elements, anti-personnel mines, hand grenades, means of initiation. The line for the disposal of small arms cartridges, small caliber ammunition and their elements has been operating at the Kisk forepost Baltic Plus in Russia since 2015. Line with rotary armor furnace row-20. Operation of the line with the row-20 rotary armor furnace at the site in Russia. Unloading of recycling products from the rotary armor furnace. Recycling products. Additional equipment to ensure the operation of armor furnaces. Belt conveyor for loading products into the armored furnace. Bucket conveyors for moving recycling products.
Separator for separation of recycling products, sleeve bullet.
Two-section hopper for collecting recycling products with the possibility of unloading them into vehicles. Gas cleaning system in the shop. Machines for opening metal boxes. A machine for opening boxes of small arms cartridges. The machine capacity is 150 boxes per hour. A machine for opening boxes with small arms cartridges, fuses, small caliber artillery cartridges. The machine can be easily adjusted to different sizes of boxes. The machine capacity is 150 boxes per hour. The planned scheme of the line for the disposal of ammunition with a caliber of up to 13 by thermal exposure. Installation for disposal of fuses of artillery shots by the method without explosion. The capacity of the installation of 1400 fuses per shift. Operated in Bulgaria since 2010. Lines for disposal of anti-tank mines.
The T-57 anti-tank mine disposal line has been operating at the Aviation Weapons Disposal Center of the Republic of Belarus since 2015.
The machine for opening cases min. Hydropress. Productivity up to 100 pieces per shift. T-62 anti-tank mine disposal lines has been operating at the federal state-owned enterprise, Sverdlov plant, in the Russian Federation since 2016. The machine for opening cases min. An anti-tank mine is installed on the machine for cutting the bottom. The bottom of the mine is cut off. Productivity up to 120 pieces per shift. A mine without a bottom is installed on the press.
Hydraulic press.
Another mine is installed on the machine. The mode of simultaneous cutting of the bottom and squeezing the explosive out of the mine is activated. Ammunition disposal equipment is located in modular prefabricated buildings without foundations.
This makes it possible to reduce the cost of creating recycling centers and significantly reduce the time of their commissioning.
Localization of hazardous production processes in separate modules significantly increases safety. The block is a modular building of 7 modules for working with ammunition. A room of the category Labama with a bouncing surface. A small-sized emulsion charger has been developed and manufactured. The charger is designed for the preparation of emulsion explosives and charging holes in underground conditions. It is used for the production of blasting operations in horizontal penetrations underground during the extraction of uranium ore, gold, platinum and other valuable minerals. The capacity for charging explosives is 25 liters per minute. The charger is serviced by 1 person.
Hidden explosion.
The hidden explosion technology is used for crushing boulders, demolishing buildings and mining blockstone. During the production of works, there is a minimal scattering of fragments, there are no seismic and air shock waves. When mining a blockstone, micro cracks are not formed in it. This technology uses components that are not explosives. No special permits are required for their transportation, storage and use. A person is near the explosion, without fear of flying fragments and shock waves. Using the hidden explosion technology when crushing boulders. Destruction of reinforced concrete structures. Extraction of blockstone by horizontal cutting. Extraction of blockstone by vertical slope. The hidden explosion technology is successfully used in the demolition of buildings and structures. STEN manufactures thermal power equipment.
Collapsible plate heat exchangers of various capacities, shut-off valves and filters.
Construction of block thermal points. The specialists of JSC STEN are ready to organize production for the disposal of ammunition of any complexity, in accordance with the technical task of the customer, to perform installation of equipment, commissioning and training of personnel.